Hello students, myself Dinkar Satunkar again welcomes all of you in this part 14 of chapter motion of 9th class physics. Dear students, this is the last part from the theory part of this particular chapter. The name of the article that we are going to see today is nothing but circular motion. Up till the last video we have studied about graphical representation of the motion, and while discussing the graphical representation we have seen that the three equations of motions can be very well studied with the help of the graphical representation. So a motion of an object can be successfully described with the help of three equations of motions, and these three equations of motions can also be determined with the help of graphical representation. In this video we are going to study about a special kind of motion, that is nothing but circular motion. In some previous videos I told you that along with a rectilinear motion, the motion of an object which is considered along a straight line path, another kind of motion is also we are going to study. At the last part of this chapter we are going to study about the circular motion, a kind of motion where the object is not performing its motion along the straight line. So this particular motion where the object is not performing its motion along the straight line, that is the motion of an object is not a rectilinear motion, then this particular special type of motion we are going to study that is nothing but this circular motion. Now the name itself suggests this circular word itself tells us that it is some kind of motion which is related to a circle. So here the object is in motion, but now this time the object is not performing its motion along a straight line. That means the object is not performing a rectilinear motion. Let me give you some examples that you can easily understand with the help of those examples that this is a circular motion. Suppose a satellite is revolving around the earth, or suppose a cyclist is there who is cycling his cycle in a circular track. So the motion of the cyclist or the motion of the satellite around the earth, those motions are considered as the circular motion. Here also I have tried to show this particular picture with the help of which I have shown that a boy is there or a person is there who is holding a string. Now this is a string or a rope where a stone is being tied to this string, and this boy is whirling this string in such a way that this particular stone performs its motion. Now but the motion of this particular stone, because it is tied to this string and the boy is holding that string, he is whirling this string in such a way that this particular stone revolves, this particular stone performs its motion. When this stone performs the motion, the path traced by this stone is nothing but circular in nature. So the object is in motion, but object is not performing its motion in a straight line. The object is not performing a rectilinear motion, but now this time the object performs its motion along the circumference of this circle. If you trace the path of the motion of the stone, then you will see that this particular path which is the stone is whirling around this string, that particular path is along the circumference of the circle. Or suppose if you consider the satellite which is revolving around the earth, then if you consider the path of this satellite, then the path of the satellite is also along a circle, that is the path traced by that particular satellite is nothing but in circumference of the circle. So this particular motion where the object is performing its motion along the circumference of the circle, or we can say that the path is described with the help of a circle, that particular motion is called as a circular motion. So if you see the definition of circular motion, then you will see that when the object performs its motion along the circumference of a circle with uniform speed is called as uniform circular motion. Now why this word uniform is attached over here? This word uniform is attached over here because the object is performing its motion along the circumference, but the speed of the object is uniform. Now purposefully I am using the word speed over here because later on we are going to define the velocity of the object in the circular motion. This difference between the speed and the velocity is specific over here. That's why when we define the circular motion, we have to define this particular motion, that when the object performs its motion along the circumference of a circle with uniform speed is called as uniform circular motion. Since the speed is uniform, that's why the motion is considered as the uniform circular motion. No doubt it is a circular motion since the object is performing its motion along the circumference of the circle. That's why the motion is circular. But since the object is performing its motion with uniform speed, that's why the motion is considered as the uniform circular motion. Now why I am telling you that we have studied that when the speed is uniform in a rectilinear motion, then the object is not performing an accelerated motion. But here the concept is little bit different, because I told you that this speed and velocity concept, in particular circular motion, there is a lot of difference. You will come to know what is the difference is specifically vital over here, because here the speed and velocity differs. I tell you later on how exactly it differs, but let's first see here that the speed is uniform. That's why the motion of an object, the object which is performing the circular motion along the circumference of the circle, is nothing but uniform circular motion. Now I have shown it one more diagram over here, that I have shown that if the object is performing its motion, now it is the path, the circle which I have shown over here is nothing but the path along which the object is performing the circular motion. So you can consider a similar kind of example, that suppose this stone is there, this string is nothing but, I can consider here, it is the radius of this particular circle. So I can say that the radius of this circular path is nothing but, let us imagine that this is nothing but r. Here also this radius is nothing but the length of the string itself, it is nothing but the radius. Now there are some important points related with the circular motion, that I will enlist some points over here, and I will describe those points one by one, so that easily you can understand what are the important points which are related with the circular motion. The very first point is that when the object moves in a circular path with constant speed, its velocity changes due to continuous change in the direction. Now here two words are very important, that the object is performing the circular motion, but this object which is performing a circular motion is with the constant speed, but the velocity changes. Now you will surprised to know that, or you will be quite puzzled that how come it's possible that the velocity is constant, the speed is constant, but the velocity is changing. Let us consider this particular diagram over here, so that you will easily understand what exactly the meaning, that the speed is constant but the velocity changes. Now if I consider the object, imagine that the object is at this particular point, imagine that the object at this particular point, imagine the object is at this particular point, or you can consider the object is at this point. Now at the respective positions of the object along the circumference of the circle, the speed is constant, because the circular motion here we are going to define this in terms of uniform, so that's why the speed is constant. But what about the velocity? The velocity at the respective points differs over here, because velocity is a vector quantity, and since the velocity is the vector quantity, here also the direction is important, because every vector quantity is that particular quantity which has the magnitude as well as the direction. So that's why here velocity which is shown at a particular respective positions of the particle, here the direction of the velocity differs. In uniform circular motion or in circular motion, the direction of the velocity of the object at the respective particular point is nothing but a tangent which is drawn at that particular point. What is the meaning of tangent? Tangent is nothing but this particular segment which is touching this particular point. So if the object is performing its circular motion in this direction, so if I draw the tangent at a particular position of this object or particle, then the tangent which is drawn in this direction shows the direction of the velocity. So if you consider the different positions of the particle or different positions of the object in this entire circular path, you will find that from every changing position, the direction of the velocity also changes. Now if you consider the object at this position, the direction of the velocity will be in this direction. If you consider the particle or of the object at this particular point, then the direction of the velocity is in this way. If you consider the object is at this particular position, then the direction will be the direction in which direction the tangent is drawn. This particular is the direction of the velocity. If you consider this particular position of the particle, then the direction of the velocity will be in the direction in which the tangent is drawn. So what we come to know this from this analogy over here, that at the changing position of the particle leads for change in the direction of the velocity. However, the speed is constant but the velocity is changing. That means the direction of the velocity is changing. And we know that from previous some articles we have studied that while discussing the acceleration, that change in velocity with respect to time is called as an acceleration. So here also, though the speed is constant, but since the changing direction of the velocity leads for the change in velocity, that's why circular motion or every circular motion is an accelerated motion. So this is the big difference between the constant speed and the changing velocity at respective positions of the particle or object over here. So that's why this particular point, when the object moves in circular path with constant speed, its velocity changes due to continuous change in the direction. This particular point is important over here. Let's see what about some other points related to the circular motion. Now since the velocity is continuously changing from point to point, in this diagram we have seen that the velocity is changing from as the point of object changes from one point to another point. That's why the velocity is changing. So that's why this motion, circular motion, is considered as an accelerated motion. Now this particular accelerated motion is without changing its speed. This point is important, that the object is accelerated but change in speed does not happen over here. There is definitely change in the velocity since the direction of the velocity is changing, but there is no change in the speed. So that's why this motion, circular motion, is also called as an accelerated motion. Now if suppose this is an accelerated motion, we know that acceleration is a vector quantity. Obviously the direction of acceleration is important over here, and definitely we are interested in finding out what is the direction of the acceleration. Now the direction of the acceleration in rectilinear motion, we have seen the if the positive acceleration is there in rectilinear motion, we have seen that the direction of acceleration and direction of velocity is same. But if in rectilinear motion, if retardation is considered, then we very well known that the direction of acceleration and direction of velocity, they are opposite to each other. Here the concept of the acceleration, particularly direction of acceleration, is something different, because now the direction of acceleration is towards the center of the circular path. Now if you consider the velocity at this particular point, let us imagine the point, this point is nothing but the object is there. So if suppose this is the direction in which velocity we have shown, or this is the direction of the velocity, but now the direction of velocity, though it is in this direction, but always the direction of the acceleration is towards this particular center of the circular path. So if you consider the acceleration at this particular point, then it will be in this direction. Now if you consider the direction of the acceleration, at this point is always towards the center of the circle, so that's why acceleration will be in this direction. If you consider the acceleration direction at this particular point, then I must say that the direction of acceleration will be toward the center. If you consider this particular point where the direction of acceleration is, then at this particular point also the direction of acceleration is always toward the center. So this point is very, very important here, that the direction of velocity and direction of acceleration, they are always perpendicular to each other at respective position. If you see the angle between the velocity and angle between the acceleration is nothing but 90 degree. Here also the direction of acceleration is in this way, direction of velocity is in this way. So here also the angle between the acceleration and velocity is 90 degree. Here also the velocity will be in this direction and acceleration is in this direction towards the center. That's why this angle is also 90 degree. At every point you will see that the direction of velocity is along the tangent, but the direction of acceleration is always toward the center. Since the direction of acceleration is toward the center, that's why this particular acceleration has a special name. This particular acceleration, now it is called as the centripetal acceleration. The meaning of centripetal is towards the center. That's why centripetal signifies here towards the center. That's why this acceleration, since it is towards the center, that's why this acceleration is called as a centripetal acceleration. Now for every circular motion there is a requirement of some force that an object continue its circular motion. If the necessary force is not applied on the object, then object will not perform the circular motion. So that's why a force is needed to produce the circular motion, so that object will continuously be in circular motion. That particular force which is necessary to keep that object in a circular motion, that force is called as the centripetal force. So here the force needed to produce the circular motion is known as centripetal force. Again, this centripetal is nothing but same meaning as that we have seen in the centripetal acceleration, since it is guided toward the center. That's why this force is also called as the centripetal force. Now in higher studies, in maybe in 11th and 12th standard, you will come to know that what is the exact definition of centripetal force and what is the other applications of the centripetal force. But at this standard, you just keep in mind that since the force is necessary to keep the object in circular motion, that's why the force which is required, that force is called as the centripetal force. Now many times in numericals will be, sometimes we have to determine the radius of this circular path. So how I can calculate the velocity with the object which is performing over here in circular path? We can determine with the help of this r and the time which is required to complete particular one rotation. So the velocity will be dealt with the help of v is equals to 2 pi r divided by t. It is the same equation that we have seen in terms of velocity is equals to displacement divided by time. Now this 2 pi r gives me the position of the object when it completes one rotation, and this t is nothing but the time which is required to complete that particular circular path. So this time and this is displacement, this gives me the velocity. So v in circular motion can be determined, the velocity of the object in circular motion at a respective point is determined with the help of v is equals to 2 pi r divided by t. I hope that the concept of circular motion is very well understood to you. Theoretical part from this particular chapter completes over here, and from the next video we will start numericals. We'll see some numericals, so that the applications of those all concepts which we have seen in the rectilinear motion or circular motion or any article which is related with the motion, that can be easily applied in the numericals. So the next videos will be on numericals. We'll see some interesting numericals depending upon the motion of an object. Thank you for watching this video.